Welcome to this presentation. My name is Mark Scythian. The date is August 3rd, 2025. So this is another continuation presentation video from the previous circuit design. So we have the same electrical motor powered by the same electrical circuit that we had built, but this time we want to redesign the circuit so that motor has low, medium, and high settings with the following specifications. So the first step is to focus on this parallel resistor here, which is dropping current. So the remaining current, 431.7 amps, goes to the motor, pushed by 12 volts to then yield at 72% electromotive efficiency, then 5 horsepower at the motor output drive. So we first need to figure out what the mechanical power output values are for the low and high settings, because we already did the medium setting as the original setting. So we want to go a little lower in power and a little higher. An appropriate metric could be 2.5 for the low and 7.5 for the high with respect to horsepower, and then 5.0 for horsepower as the middle or medium. So we can then solve for the electrical power input required by dividing the mechanical power output into the efficiency of the motor. So now we know the electrical power that has to switch between the low, medium, and high settings. So next we would remove this resistor and we would replace it with an adjustable resistor. And then we would delete the original resistor values, because now we have a range, not a constant resistance. So we can take the medium current drop out and focus on the low and high settings. So we would take the electrical power input at low, divide it by the voltage to calculate the amperes that must go to the motor, the DC current that must go to the motor. And so we can repeat this process for the high setting. So now we have the resistance range. We can then build into the adjustable resistor, whether it is analog soldering of resistors or digital programming, better yet, a potentiometer. So of course you could use a dial method, but it's setting the limit. So when we divide the constant voltage at parallel into the resistance, we then get the current drop. So we would divide the voltage into then the amperes or the current drop to get the resistance. So our voltage divided into our amperes is then calculating the resistance. So that would be the voltage into each current drop requirement for the required current to each motor setting. But then we flip it around, so the voltage is dividing itself into the amperes drop to then yield the resistance values. So now we can do the rounding to 2 significant digits. And so we have our resistance values. So now after replacing the non-adjustable constant resistor value with an adjustable resistor with values, we can now then either solder in or program the resistance range from low, medium, and high into this adjustable resistor here. And so now we are complete. So when you turn on the motor and make this setting at low, you'll have 2.5 horsepower at the motor, and then at the medium setting 5.0 horsepower, and then high 7.5 horsepower. And apparently we have enough current to make this work because we have not run out of current here. And then additional information is if you're interested in the RPM accrued at these different horsepower settings, you can simply measure the torque at low and high because we already have the medium RPM value. So measure torque at low and high settings, then use the brake horsepower equation to solve for low and high RPMs. Thank you for watching this presentation and have a great day.